Now, if suppose we are using mild oxidizing agent as, let us say, now what I am going to do is I will be first of all telling you few of the strong oxidizing agents, then I will be telling you few of the mild oxidizing agents. Based on the strength of these, you can easily decide the fate of the product. So the examples for the strong oxidizing agents which we have are something like, suppose we have first of all we have like potassium dichromate, that is K2Cr2O7. Now you can add in the three. Now you can add potassium dichromate in the two mediums. One is in the acidic medium, another is in the basic medium. Now it will be represented as K2Cr2O7 H plus in the presence of H plus or in the presence of OH minus. Now like I told you, for the 3-degree alcohols, if the reaction conditions are acidic in nature, then 3-degree alcohols undergo dehydration to form alkene. So if you add a 3-degree alcohol and a strong oxidizing agent in the acidic conditions, like just now I told you we have K2Cr2O7 in the presence of H plus if you add. So what it will form is that 3-degree alcohol will form a alkene. Another reagent which you can use as a strong oxidizing agent is the potassium permanganate, that is KMnO4. And in this actually what we have is this, we can add this KMnO4 in 3 different mediums, like we have acidic medium, we have basic medium, we have neutral medium also. So be it any medium, the function I have told you, it is a strong oxidizing agent, and that strong oxidizing agent in the 1-degree alcohol converts it into the carboxylic acid, whereas in a 2-degree it converts 2-degree alcohol to ketone, and 3-degree alcohol will not undergo any oxidation if you add KMnO4 in the basic medium or the neutral medium. For instance, KMnO4 in OH minus and KMnO4 in H2O. So under these conditions, 3-degree alcohol will not undergo any kind of the reaction. The other strong oxidizing agent which you can use is like chromium trioxide, that is CrO3, in the presence of glacial acetic acid, So this is also a strong oxidizing agent. Another reagent which we use as a strong oxidizing agent is the dilute HNO3, which is 71%. So now you can observe or you can see that even a dilute solution of HNO3 is oxidizing alcohol to carboxylic acid. So that means even a dilute solution of HNO3 has a very strong oxidizing capacity. So these are the few examples. Another example we can use as a strong oxidizing agent is the chromic acid, is H2CrO4. What it does is it oxidizes 1-degree alcohols to carboxylic acids and 2-degree alcohols to ketones and 3-degree alcohols, basically in the presence of chromic acid, because chromic acid itself is an acid. So we do have acidic conditions. So 3-degree alcohol in the presence of chromic acid undergo dehydration to form alkene. So these were the few examples of the strong oxidizing agents. Now when we come to the mild oxidizing agents, we have something like PCC, which is known as pyridinium chlorochromate. Then we have in the mild oxidizing agent, we have another one, that is PDC, which is known as pyridinium dichromate. Then we can use H2CrO4 again, that is a chromic acid in the acetone. And what it does is basically, see, just now I told you chromic acid being a strong oxidizing agent, but when you add acetone into it, basically the reaction conditions become less vigorous, and hence the oxidation of a primary alcohol stops at the aldehyde or the ketone step only. It does not undergo any further oxidation to the carboxylic acid. So that is why H2CrO4 in the acetone is basically a mild oxidizing agent. And these were the few examples of the mild oxidizing agents we have. Well, the next we have is this, that you have a alcoholic group, that is OH group in the compound, and also you have a double bond in the compound, but you want a product something like where the double bond is not being reacted, but the OH group of the alcohol